Have you ever stopped to think about the sheer magic resting in the palm of your hand? That smartphone you use to order food, watch videos, connect with friends, is a supercomputer. Seriously. The phone in your pocket today has more computing power than all of NASA had back in 1969 when they put a man on the moon. It's an incredible thought, isn't it? These little devices reshaped our world, from how we work to how we fall in love. They are built on tiny electronic switches called transistors, etched onto silicon chips. These switches can be either on or off, a 1 or a 0. This simple binary system is the foundation of our entire digital universe. For decades, this logic served us brilliantly. Engineers made transistors smaller and smaller, packing more power into tinier spaces. That's why your laptop is thousands of times more powerful than the giant, room-sized computers of the past. But what happens when we can't make the switches any smaller? When we reach a physical limit, we're getting very close. When we hit that wall, we need a new kind of thinking, a new kind of computer to carry us forward. That's where the story gets really exciting. Let's break this down. Your everyday computer is a classical computer. It thinks in bits. A bit is the smallest piece of information, 0 or 1. Think of a light switch, on or off. Everything you do is sequences of zeros and ones, millions of times a second. Now the weird and wonderful world of quantum mechanics. A quantum computer uses qubits. This is where things get mind-bending. A qubit isn't limited to just 0 or 1. It can be 0, 1, or both at the same time, like a spinning coin. It only settles when we measure it. Qubits have another superpower, entanglement. Two qubits become linked, across a room or across the galaxy. Measure one as 0, and you instantly know the other is 1. This lets quantum computers explore millions of possibilities at once, a fundamentally more powerful way to compute. Classical is like trying one path after another. Quantum explores every path at once, a single grain of sand versus seeing the entire beach. For a long time, building a quantum computer felt alien. Exotic materials, massive machinery, and ultra-cold temperatures. A tiny vibration or stray magnetic field could destroy fragile quantum states, decoherence. Early systems were groundbreaking but expensive, enormous, and hard to scale. Millions of qubits felt like a distant dream. Then in 2015, a team led by Professor Andrew Zurak at the University of New South Wales announced a world first. A quantum logic gate built using silicon. The same material in your phone, laptop, and camera. It sent shockwaves through tech. Suddenly, the path to large-scale quantum computers looked clearer. A complete game changer. Instead of inventing new metals and tools, they used our existing factories and know-how. By tapping the multi-trillion-dollar semiconductor industry with decades of precision chip making, they essentially tricked a standard silicon transistor to behave like a qubit. Packing millions of qubits on a chip no longer looked like sci-fi. We already make billions of transistors. Now imagine turning them into qubits. This bridged exotic quantum physics and practical electronics manufacturing. The quantum age suddenly felt closer. Why is silicon such a massive deal? It's abundant, refined to extreme purity, then formed into wafers, the canvas of our digital lives. Silicon is the foundation of the information age. For 70+ years, we perfected making silicon chips, building colossal global fabs that etch near-atomic patterns. If a quantum device is silicon-based, we don't reinvent the wheel. We can use the same tools and factories producing billions of chips, solving quantum's scalability headache. Handcrafted prototypes struggle to become million-qubit processors. Silicon points a clear path. Silicon qubits can be surprisingly stable and long-lived, helping fight decoherence. The silicon structure shields qubits from outside noise, enabling longer calculations with fewer errors. It's like discovering the cheapest building material is also among the strongest. The perfect combination of practicality and performance. How did UNSW do it? Turning everyday silicon into a quantum component. They reused the MOSFET, the basic switch in chips for your phone and computer, reimagining a device we already build perfectly. They reconfigured a standard silicon transistor to trap a single electron. That single electron became their qubit, using its spin. Imagine a tiny magnet. Spin up equals 1, spin down equals 0. With precise electrical fields applied through the transistor's metal gates, they nudged and flipped spin with incredible accuracy. Place two single electron qubits close together, make them interact and entangle. Control one electron spin based on its neighbor. That's a 2-qubit logic gate. A logic gate enables computation, like meshing two gears. From there, you can build complex machines. Crucially, It's compatible with CMOS, the dominant process for integrated circuits. This wasn't just a lab trick, it's a blueprint industry can adopt. Foundries worldwide could integrate these ideas. The dream of a quantum chip moved from physics lab to electronics factory. By the way, if you have not subscribed to our channel, please do that. It encourages us to bring more informative content to you. What can a quantum computer do that your laptop can't? Solve problems of staggering complexity. Not faster games or quicker spreadsheets, but challenges impossible even for today's supercomputers. Designing new drugs or industrial catalysts means simulating complex molecules, a native quantum problem. Quantum computers speak the molecule's language, enabling perfect simulations. That could accelerate treatments for diseases like Alzheimer's and create ultra-efficient solar panels and batteries, a perfect digital chemistry set. Optimization is huge. Think delivery fleets with routes exploding into trillions of possibilities. Quantum can test many solutions simultaneously and find the best fast. Encryption today relies on factoring big numbers. A powerful quantum computer could break it using Shor's algorithm. The good news? Quantum-safe methods are in development, and quantum tech can help create truly secure communications. Creating quantum logic in silicon was more than curiosity. It fired the starting pistol for a new technological race. It reframed quantum from heroic one-offs to scalable, manufacturable tech. The future will be hybrid. Quantum won't replace your laptop for emails or your phone for scrolling. Classical remains great at that. Instead, a quantum coprocessor in the cloud will tackle the hardest parts on demand. Expect leaps in personalized medicines, AI that understands complex data, materials transforming energy and transport, and robust financial models. Immense challenges remain. Fault tolerance, millions of stable qubits, but the path is clear. By marrying quantum mechanics with silicon manufacturing, we've laid the foundation. The same humble element that gave us the digital age will usher in the quantum age. The quantum revolution is being built, one silicon atom at a time. Let us know in comments, what do you think can quantum computers achieve in near term? Do you think in next 1 decade quantum computers will be more accessible to common people? If you are a science and technology buff, do subscribe to our channel and like this video so that it reaches more like-minded people. See you later with more of such content.